Well, hey everybody, Mr. Reeves back with you, and today we are continuing our look at the Pythagorean Theorem, and more specifically, we're going to be looking at the Pythagorean Theorem in 3 dimensions, and even more specifically than that, we're going to be looking at diagonals of rectangular prisms. All right, so just a reminder about the Pythagorean theorem. What do we use the Pythagorean theorem for? Well, on a right triangle, we have the right angle formed by the two legs, which we call A and B, and the segment connecting each leg is called the hypotenuse, which we label C. And what we talked about was the relationship between those lengths is A squared plus b squared equals c squared. And given the two legs, you can find the length of the hypotenuse, or given the length of the hypotenuse in a leg, you can find the length of the other leg. All right, but here we go. You can also use the Pythagorean theorem in a situation like this. All right, it says a box is used for shipping narrow copper tubes, and it measures 6 inches by 6 inches by 20 inches. All right, so here's our length going across here, 20. Our width is 6, and our height is 6. All right, what is the length of the longest tube that will fit in that box? All right, so we're going to be asked to find that length R, and we're going to do it by using the Pythagorean theorem twice. That's right, twice. Isn't this exciting? Using the Pythagorean theorem once is amazing. Using it twice is even more amazing. All right, so let's start by finding this length S here. Okay, so if we look from here, that length S we're going to find. All right, but we're going to do that by using this right triangle at the base. All right, because this is a rectangular prism, let's see how I can do here. All right, because this is a rectangular prism, this triangle down here on the bottom, that's a right triangle. Okay, right there, that part I colored in. So that is a right triangle, of which S is the hypotenuse. All right. Okay, so we know that this is 20. If we look across, we can see that this right here is 6 inches. So to find S, we know that 6 squared plus 20 squared is equal to S squared. So if you look right here, that's what they're doing. Here we go. 6 squared plus 20 squared is equal to S squared. 36 plus 400 is equal to S squared. I'm going to go ahead and scroll down here so we could see the rest of the work here. So S squared is equal to 436. What they did not find was S. So if we were to take our handy dandy calculator, all right, if we were to put in the square root of 436, we would see that S is approximately 20.9 inches. All right, so that's what S is approximately. So if I go here, it's approximately 20.9 inches. But keep in mind that is a rounded value, and every time you round, it gets less accurate, right? Okay, so now let's go ahead and say, oh, we know our goal. Remember, our goal is to find R here. That's what we really want to find. Whoops, I didn't want to use that color. All right, R is what we really want to find. Well, if we take a look here, we have another right triangle, don't we? Right here. All right, my squares need some work. Actually, that one's a little better than that one even, isn't it? So if we take a look at this right here, this is our right triangle that we have. Coloring is so much fun. All righty. All right, so we know that the height right here is also 6 inches, right? So this is 6 inches. This is about 20.9 inches. And here is that radius that we don't know. So when we go to do that one, right, that's going to be 6 squared plus 20.9 squared equals r squared, right? But remember how this was an approximation, all right? We knew what this was exactly squared, which is why down here they did not bother to square root it, because we knew we wanted it squared, all right? So if we look right up here, all right, here we have h, s, and r, so we know that h squared plus s squared is equal to r squared. So we don't really even need s, we need s squared. Does that make sense? All right, so that's why in the book they did not bother to square root it, because they knew we needed it squared. So right here we've got 6 squared plus 436 is equal to r squared. So r squared is 472. So, all right, so h squared again plus h squared plus s squared is r squared. And we get 472, 472 is equal to r squared. And that's when we go ahead and say, okay, well now I'm going to take the square root. The square root of 472 is, when we round off to the nearest tenth, 21.7. 21.7 inches. All right. So given that the length of the two must be a whole number, all right, well, if you take a look, 20, it's not 22. It can't be 22. 22 would be too big. So 21 inches would be the biggest we could have if it was a whole number. Because if we did 22, this rounds up to 22, right? But that would make it too big. So 21 is the answer that we are looking for. All right, but let's take a look real quickly here and see what actually happened. For the first one right here, we had w squared plus L squared equaled s squared, right? And then for the next one, we had s squared plus h squared equals r squared. Well, take a look. See this s squared here and this s squared here? They're the same thing, aren't they? So there's this thing in mathematics called the substitution property. And the substitution property says if two things are equal, then you can replace one for the other. So remember, our ultimate goal was to find r squared. So if I wanted to do it as quickly as possible, instead of doing w squared plus L squared and finding s squared, I could simply do this all in one fell swoop. W squared plus L squared plus h squared equals r squared. And there, what do we have? We have the Pythagorean Theorem in 3 dimensions. 3D Pythagorean Theorem. Isn't that cool? Instead of a squared plus b squared equals c squared, we've got width squared plus length squared plus height squared is equal to that diagonal squared. All right, so once you know this, it makes your life much easier and will make things go faster. So let's go to the next page and look at this example here. All right, so again, we've got our length, we've got our width, and we've got our height. All right, and what did we just say? We just said length squared plus width squared plus height squared is equal to r squared. We can even take this one step further. Remember, if we don't really want to know what r squared is, we want to know what r is. So what about if I take the square root of this? The square root of length squared plus the square root. Sorry, the square root of length squared plus width squared plus height squared is equal to r. And then we got r in one step, putting all this in, right? So for this problem right here, r is equal to the square root of, what is it? It's going to be 14 squared plus 4 squared plus 4 squared. All right, so I'm going to go to my handy dandy calculator. Here we go. All right. And I'm actually going to find out what that value is. 14 squared plus 4 squared is 16. 4 squared is 16. When I add all those together, I get the square root of 228. Okay. And rounded to the, we'll round it to the nearest tenth first. So we'll do the square root of 228. And when I do that, I get 15.1. And these are inches. Okay. All right, what is the greatest length in whole inches that the part could have been? Well, 15.1 inches is bigger than 15, right? That's greater than 15, which means if that distance is greater than 15, then 15 inches will fit. All right, it's just a little bit bigger than 15, which is perfect for a 15-inch item to fit there. All right, so if you want to know the diagonal of a rectangular prism like this, okay, the thing to do is that Pythagorean Theorem formula in 3 dimensions, length squared plus width squared plus height squared equals that diagonal squared, or simply take the square root of the sum of the length squared, width squared, and height squared. And that will work every time. Pay close attention to rounding and the question it asks you to make sure your answer is correct. All right, well, I hope this video was helpful for you as we looked at the Pythagorean Theorem in 3 dimensions. Until next time, have a great day. Bye.